Hello, this is a quick review of my code for the Arduino and how it's going to be interfacing with the Raspberry Pi. Very quickly, we have I2C set up so we can get roll, pitch, and heading information from our EN.605.715 sensor and send that out on the I2C bus. So using the wire library, we initialize the Arduino to connect to the bus as a slave on address 18, and when queried, or when requested, it responds with the respond to C interrupt handler, which you'll see down at the bottom of the program later. Then you have the standard stuff, initializing the IMU sensor and LED output pin modes and things like that. In the main loop, we're just pulling the sensor over and over again to get the latest heading, pitch, and roll, making some corrections and converting values to strings and then printing that string to a buffer. I have disabled interrupts when I'm writing to the buffer, so the interrupt handler does not read from the buffer as I'm writing from it. For debug purposes, I'm also sending the buffer to the serial console for debug. Also toggling an LED on the Raspberry or on the Arduino to make sure that the task is running as a visual sanity check. And here we have the interrupt handler down here at the bottom. And it simply just writes the buffer to the I2C interface or bus. That's it. Alright, over on to the Raspberry Pi, we'll see how I'm collecting I2C data from the Arduino. So this is a little C++ program for reading from the I2C bus on the Raspberry Pi, defining the Arduino's address here, and this is I guess a definition for designating a device at an address as a slave. I pulled this from the Wiring Pi libraries, which are now no longer supported on Raspbian, but the code is still available, and this is where I got that information from. Basically, we're just opening the file descriptor. I2C is on the Raspberry Pi at /dev/i2c-1, and here we are opening that. Returning errors if that's unsuccessful. Then using the ioctl system call, identifying device at address 18 as a slave device. And here in the main the loop of our program, we're just constantly pulling the that device, reading from it, and spitting out what we get to the standard console, and then delaying for 100 milliseconds, which is the IMU's update rate. So that's that. And here's a demonstration while we're on the ground of how we'll be connecting everything. So we'll launch the project.bash, which will launch the various services. Here we'll get the IMU going. Have that over here. We'll get our GPS display up and connected here. And you have that long altitude there. And then video. we'll get started here. It's nighttime, so the drone is camera is a little dark, but if I'll just wiggle the drone, you can see things are updating with a little read error, but it's there. And so that's everything that we'll be seeing during flight. So we have live video, IMU data, and GPS lat long and altitude. And so now we'll demonstrate that data being captured in flight. All right, just a little bit of fun at the end of the project. All right, that was pretty fun.